That's great. Now, today we will complete our discussion on DMA, and then we'll start our discussion on microcontroller. New IC, or rather we can say some extension of what we have studied so far. Okay, so let us quickly complete what we have discussed so far regarding to DMA, and then we will switch uh, to the next topic, that is controller. Okay. Um, Let me know if the screen is not visible to you. So what we concluded last time, that we have various registers, and we learned about the uses of those registers, right? And we also learned that if we want to go to particular register, like if I want to mask my channels, then I will use mask register, right? If I want to go for individual mark set reset, then I will go with this register, that is mask register set reset. Mode will bus request will do that software request, the DRQ request that is generally done by IO, but now it will be done by software, right? So that is nothing but a bus request, we want the bus and we want the access to bus. That is what the bus request register is. What is the mode register? Mode register is regarding what kind of mode we are going to adjust. That is, it is a read or it is write. Can you close that door, please? Can you close the door, please? Okay. Um, Okay, so that is what in each channel we are going to have the demand mode or single mode or block mode or cascade mode, right? Or whether it will be read or write operation on the particular channel that we have selected, whether it will have auto initialization or not, whether it will have auto increment or decrement, right? All those things will be adjusted in the mode register, right? What will be the command register? Command register will say that is it memory to memory transfer. If it is memory to memory transfer, then is it that one data is copied to all, like that data is held in channel 0 and it is copied to all other, whether we should keep our controller enable or disable, and all those things are that whether we should have that this the request register high or low, right? So in that way, whether it is a fixed priority or rotating priority, all those things we have learned earlier. So that is the command register. So now what is the next point? This, if I want to go for these registers, I want to set something to register, so I have to write like move this data to this register, this register. But how to access those registers, right? For that, it is given to us that, like, if this combination of A0 to A3 happens, A0 to A3 means they are lower address lines, lower 4 address lines, right? If this combination of lower 4 address line happens, then you are going to access the register which is a status register, right? But status is only, you can read the status only, you cannot write the status, right? You have to just read the status. That is why only option that is available, that read status register. And that's why if you are reading, then your reading line should be 0 and writing line should be high, that is, it should not be activated, right? So if this combination happens and if read signal is high, that means you are going to read your status register. You are not going to read the command register, you are going to write to command register, right? So that's why you have to you will provide the command, that means you will write to command register by having this combination of A0 to A3 and having that write signal activated and read signal not activated. Uh, you are going to keep you are going to access your command register. So once I want to access my command register, I need to keep my A3 to A0 in this combination, right? Of course, I need to use out instruction or something that will write to that. That means this should act as a destination, right? That is the next thing. That means this command should be activated, this line should be activated. And one more thing is that what should be the value that I will write, that will be decided by these combinations. So whatever we have studied, like this combinations, right? So whatever I want to write, that will be my content. Where to write, that was the combination of A3 to A0, and which operation to perform, right? That means this address must be in the destination, then and only then write performance, right will happen. This is bus request, this is single mask, this is most that mode register, right? And this is clear mask register. So different register that we have studied, all those that addresses are written here. And most of the registers you can just write them, like you can write to request, you cannot read the request, right? If you want to read, just status register is available for the reading purpose. See, if so that's why whenever this address happens and this combination where read is activated is an illegal operation. That means you cannot read the request register, you cannot read the single mask register, you can just write to them. And if you want to read the status, you have to go for the status register. That is what the point is. Now, next was clear byte pointer flip flop. That if this flip flop is 1, then it is a what will be the value if this flip flop will, that is a flip flop, right? If it is 0, that means what you are going to access, lower address byte, lower byte of the operation you are selecting. That means one by one you are writing, right? You are just having 8-bit data lines. So whichever data is available, that is lower byte of address, that is indicated by this flip-flop 0. And if whatever data is available in the data line, it is higher order, that will be indicated by 1. Suppose you want to intentionally read or write a particular lower or higher byte, then you can adjust it. But otherwise, if you are not doing it, then it will automatically toggles. That means, of course, if you want to read 16 byte, first it will be 0, then it will be 1, so on. Okay, one more command. So if you want to handle that flip flop, if you want to clear that flip flop, then you are going to access this address. This is the address to access your what you can say, your flip flop. That is 1100. A3 to A0 should be 1100. So this you have to keep in your mind, that these are the values of A3 to A0. Now, what is the next thing? That one more command that we need to learn is master clear. What is master clear? It is just like a reset, but it is a software reset. That's it. Reset is what, that all channels are disabled, all the registers are 0. They are in the default mode. So master clear is a reset, but software reset kind of thing. Then next is clear mask register. Clear mask register is the instruction, or we can say, if you are activating these lines, if you are activating A3 to A0 in this manner, then it will activate this command, which is what, that clear mask register. What is that? That all 4 DMA channels are 0. They all are 0. That means they are not masked. That means they are all enabled. Okay, so that if it is 1, that is it is masked. If it is 0, that means they are not masked. That means they are enabled. Okay, so that is all about this. Up to this we have already discussed. This was just a revision. Now we are going to the next actual part, right? Now, so now what do you think, what we are going to do? First of all, we will adjust our mode, we will give the command, right? So from microprocessor we are going to have that what should be the value of mode register, what should be the value of command register, etc. That things we will adjust, right? Those things we are going to adjust. Now after that, what will be the next thing? The next thing will be you have to write that how many bytes you are going to read, how many bytes, like the count that you are going to write or read, how many bytes, that count you need to write, right? And then you have to give the current address as well, that what will be my current address. So from that you need to start the operation. So all those things you need to adjust, right? So if you want to adjust base and current register of, that is base address, or rather we should say what we can say, the address register of channel 0, where the initial address will be stored. So what should be the combination of A3 to A0? It should be 0000. If you are going to handle that address register of channel 1, it should be 0010, right? If you are going to adjust base current register, that base register, I mean, not, it is not incrementing, it is initial address which will be stored permanently, it will be not altered, right? And whenever auto initialization mode is there, at that time that will be copied, that register we are talking about. So if that base and current address register, that is initial address, if you want to store, this should be the combination of A0 to A1, that is all zeros. And same way this should be 0010, this should be 0100, and so on. Okay, now what should be okay, so now that is all the, these are the things, right? Now if you want to if you want to write the current address, again the combinations of, in short, what is the point, like the word count register, this should be the values of a3 to a0 that we must have to adjust our particular registers here, right? So let us see the programs and it is going to help us more, right? So fine, so let us go to example directly. What the example says that 8237 decoding circuit we have to design. The address line connection should be such that that address range is in 7027FH. Okay, so whatever the address lines you have in that, the address should be 7027FH, and you have to start in a block memory mode. You have to transfer the in block memory, and what should be the locations? This is the starting location and this is your destination location, and channel 0 you should use as source and channel 1 you should use as a destination, right? So many things are provided here, right? So let us go one by one. So first of all, here something is provided. This is more important, right? So of course we will come to this point. This is actually important, this part. What it shows that you have status register whose value is 78, right? See, this is actually this program, this is done in masm, it is not done in tasm. So possibly you will feel like it is having different structure, right, of your program. But here what our purpose is, our purpose is to learn that how to program. Of course you can write those programs in tasm as well. So that is not the problem, that how the program is written. So don't go with the syntax, that is not our concern. This is our study in terms of that how to handle these things, right? How to I mean that program what to write is a concern. How to write is, that is of course you can write in any TASM code you can make from what, if you are clear with what to write. Okay, so now what this part does, this part gives addresses to status register, this request register, mask register, command register, mode register, right? Channel 0 address, channel 1 address, and channel 1 count. And this is your clear flip-flop. Okay, now what we have to do is, what we have to do is okay, so now so what is given to us, of course I will come to this point that how to give this addresses, that is a next concern. But now suppose I have this addresses. Now let us keep this point in a side, that I have this addresses. I know that how to access mode, how to access command register and all those, right? If I know this already, suppose I know this already, then what to do? So first of all, because you will start with your lower byte of address, you are going to clear this for the safe side, right? You don't know what is the previous state of your flip flop, right? So what you will do, you will clear it so that it will first access the lower byte. Okay, so that's why for the safe side you are clearing your flip flop, then it will automatically toggle when it will be required. So what you are doing, you are taking your AL value 0 and you are clearing your flip flop. That means you are writing the address of flip flop here, and that address is 7CH. How it will come, that is the only concern that we will see later. Okay, then what I have to do, then I have to take source address here. That I will take the source. Okay, so I will put that source address to what, in channel 0. I need to put my source address to channel zero's address. And of course I can just put it into because I have only D0 to D8, only 8 data bytes. So what if I want to keep 16-bit address, then I have to go twice, right? So this is first what I did, that AL I shifted to channel 0, then I shifted AH to channel 0. So in channel 0 I kept the source address. Now only thing only thing remaining is what, that how to adjust this source address, right? So for that, if you remember, this is given to you. This is given, this is your source address. Now what should be what will be your DS content, or what should be your segment address content? Suppose I am saying that I am using ES as my segment register. What will be my ES segment register content? What will be my ES register segment content? So it will be 1000, right? And what will be my offset, that is SI content? If I want to create this address, what should be my ES content? It should be this. And what should be my SI? Can you tell me? What should be my SI? It will be 0000, right? It will be 0000, right? This should be my SI content. So that is how I am going to store this, right? Suppose I want to create this destination, and if I want to keep destination offset in DI, can you tell me what should be my value of DI if I want to create this address, and if I want to use ESDI as a combination? I want to use ESDI as a combination for this destination address. Can you tell me what should be the content of DI? Should it be 1400? Sagar, try to think. It should be 1400. What it should be, try to think. I want to create this address. My segment address is this. So how what should be? Yes, it should be 4000, right? It should be 4000. Why? Because how to create the address? I will add extra 0 here and I will directly add DI to that. So DI will be 4000. So this content, this information I am going to store in channel 1. This information I am going to store in channel 0. But I can how what to store? See what actually to store. So what will be the initial address? So initial address will be like ES. Initial address is, this is ES, then extra 0, that is extra 0, right? And my offset, that is 0000, and whatever the combination is, that will be my address. So this should go to channel 1, channel 0's base address register or address register. Then what will happen? That will be copied to current address register, and then current address register is also having the same value, that is 1000 current address register. Now can you tell me what how many address lines I am having totally here in my 808 in my 8237? How many addresses it can access at a time? How many addresses it can access at a time? If you remember, how many address lines 8237 is having? 8237 is having how many address lines? How many addresses? It is 16, right? It is 16. It is 16, true. It is 16. So, so what will happen? Like here, only this 16 bits that can be stored in base address register and the current address register of channel 0. And what will happen in current address register, the same thing will get copied. And what will happen then, in the next value, it will get incremented. What are those last values? They are 0000, right? This will get copied to channel 0's base address register, and then it will be copied to current address, and the current address will get incremented after each operation. Then it will be 01, then it will be 102, then it will be 03. In that way it will reach to 13FFF, and that how when to stop that count will be stored by in the count register. We are going to store that count, so we will stop at whenever this location will come. So what is the point here? This value will be initial value of your channel 0 address register. This value will be the end value of your channel 0 address register, and of course I can handle only 16 bit at a time. So this, which are represented by A19 to A16, if you remember, A19 to A16 lines are used to represent this value, that should be hardwired, and it is going to remain same for you. See, it is going to remain same for you in this case even, right? So what is the requirement whenever you do this hardware connection, whenever you adjust your DMA, because at a time you just can handle just 16 bits, that is 64K location at a time, you need to hardwire these lines. I told you earlier also, this we have already discussed. So you are going to adjust A9 to A16 such a way that whenever the combination of A9 to A16 becomes 0001, the chip will get selected. That is, it is hardwired, right? So we will not be concerned about this this earlier lines. What we have assumed, it is hardwired. Okay. So now what we have to be concerned about, that this value should get loaded into channel 0, and whenever it is 1000 extra 0, this is ES, and then 4000, right? And this should be like 4000, 1400. Out of this 1400, only this value is getting loaded to, what? To channel 1. Okay, so now what I have these two values. From that I have to create this value. I have these two values, and from that I have to create this value, right? So how to create that general, here right now what is the case, like di itself is this value, but suppose if you don't have that, this combination is somewhat different, right? So what you have to do, what is the general procedure, that you are taking es value, then you are adding extra 0. That means you are left shifting it, and that's why you are left shifting it for the 4 times, and that's why extra 0 is getting added here, right? So that is what we have done here. You are taking es value to ax, that means 1000, that is came to ax. Now you are left shifting it for the 4 times, that means this one will out, it will not be in ax, and then 000 and extra 0 because of 4 left shift will be introduced. Why that happened? Because you need to add extra 0 here. I hope you are getting the point. Okay, that is how you are getting your this portion you obtained, right? And then you added what? Si. What is si? Si was 0000. That is what you added. So that is what you added to ax, and whatever is created out of that lower byte is moved first, and higher byte moved later. Is it making sense to you? Up to this, are you clear with it? Why shift left is done? See, actually, I have to create the physical address. For the physical address, I have to add extra 0. What is the meaning of adding extra 0? That means you have to remove the first letter, first hexadecimal digit, which is created of 4 bits, and then you have to, instead of that, you have to add extra 0. Why we are not concerned about this one? What we have assumed here, that it is hardwired. So whatever the values of that higher byte is, it is already all the time it is adjusted to 1. Is it making sense now? Are you clear up to this point? Yes or no? All of you, are you clear up to this point? Okay. Now tell me what should happen with it's the same thing. If I want to repeat with di, what should be done? Can you tell me the code for channel 1? What should happen with channel 1? What will be the first step? That es will be taken to ax. Then what to do? Suppose es is taken in ax, so what will come in es? Es is this 1000, that is taken in es. Then what to do? Shift left. Yes, we will shift left by 4, right? Then what to add? 4000 di should be added. Yes, so es is taken, then left shift, then add di, and then take it to channel 1, then higher byte to channel 1. Is it making sense to you? Why 1 by 1? Because I am putting this data to this. That means I'm using data lines here, and data lines are just 8-bit. That's why I have to go twice. And here it is automatically toggling my flip-flop. That is internal one, right? So that is automatically getting toggled, and that's why I have to first make it. It is toggling just, right. It is not starting with 0. So what if? So you have to clear its initial state, and then you can start with. So it will automatically toggle, and you will not be just worried about it. Okay, so now initial addresses are just, now what is remaining? That okay, so initial addresses are adjusted. Now you have to stop whenever this gets completed, right? So what you have to write here is, in count you have to write, right? Whatever the count is, right now we are not concerned about the count. Whatever your count is, that count, whatever your program count is, that count you are going to write to your channel 1's count register. Move to channel 1's count register. That count you are moving. Why decrementing 1? If you remember that count register itself, that is, if you remember in the count address that we have seen, the count register we have taken, in that if 10 is loaded, then 11 bytes are transferred. So suppose if you want to transfer 10 bytes only, then you have to write the code 9. If 9 is written, then 10 bytes are transferred. So whatever the count you decide, suppose you want to transfer 100 bytes, then you have to write the count 99 times. The count should be 99. So whatever count we had, and then you have to decrement it by 1. Why? Because of that internal management of your count register, and you have to decrement it once, and then you will make it to channel 1's count. Okay. Now, what is the next thing that we need to do? We have to program, or we need to program or program. We need to write mode register. Then we have to go for the command register. Everything we need to adjust, right? So let us go with this value. Like let us decide the program mode. Okay. So count up to this. We have written the count, right? We have written the count up to this point. Okay, so by twice, because the count, you know that it is 3FF is a count, right? If you will see here, the count is large, 3FFF is the count. So that you have to write twice. Okay, fine. Now we are going for the mode selection. So that is also important. So let us learn once again. What we need to do is block transfer. The block transfer is required. Channel 1 should be, channel 0 should be the source, channel 1 is the destination. That is what is required. Okay, so let us go with the mode register. And what will be the value of the mode register? This is mode register. So first, you suppose you are selecting channel 0, you are adjusting channel 0 first. So these two values will be 0, 0, right? Now channel 0 is source. So are you going to read it, or you are going to write in it? If you are going to, if channel 0, yes, you are going to read from it. So what should be the value here? It should be 1, 0, right? Then you are you don't want auto initialization. You want to do that operation only once, so it is disabled, right? And what you want to do with, you want to do address increment or decrement. What is the requirement? Are you going to increment or decrement the addresses? What is your requirement here? I mean, you have initial address, then are you incrementing the address, or you're decrementing the address in channel 0? You are incrementing it, because initial address is 1000, you are going to 13FF. So you are incrementing one by one every time. And which mode of operation we need to select? It should be what it is, 10. What, see, single mode is what? I can repeat. What is single mode? Single mode is that once I will transfer one thing, then I will ask, I mean, one location I will transfer, I will ask, can I use the bus? Then I will get acknowledgement, then I will continue. Again, I will transfer one. That is single mode. After every operation, ask your processor that, can I continue? And what is demand mode? Demand mode is that either processor will stop, that is end of process will be there, or what will happen, like if your IO will say by sending D request negative, I mean not negative, the altering the D request, whatever it is, that if it is positive selected, then it is sending negative. If it is negative selected, it will send positive. In short, your IO will say, no, I don't want to transfer, I don't want to continue. So that will be your demand mode, right? But here it is given to us, it is, we want to transfer a block of information, that is from 0000 to 3FFF. So that is a block mode. See, here it is given that this block we want to transfer. But if it is not given to you, then also by description itself, you should be able to select out of this 3. Cascade mode, we will not take that. I mean that will not be that is, we are not going to take that cases right now. So you can then also you can understand, even you should be able to program your register, mode register in the cascade mode. But more details we have not taken, so that is okay. But here it is itself is given, so yes, answer will be 10. You are correct in that way, it is 10. But you must understand, even if description is not given, you should be able to identify this out of these 4 modes. Even cascade you should be able to identify at least, right? So of course all 4 modes you need to understand. So this is fine. So this is so what is the mode register value for channel 0? So what is this? Can you give me the hexadecimal value for this, so that we can keep it inside and remember? Yes, it is 88. So value is 88. Value is 88. right? For channel 0, just keep in your mind. Same way, can you repeat for channel 1? What will be this value? It will be 8 9. Will it be 8 9? Here I am getting the answer. It will be 8 9. Verify. Will it be 8 9? So this will be 1. Will it be read mode or write mode? Will it be the read mode the same thing? No. Channel 1 is in the read mode or write mode? Yes, it is in write mode. So what should be the value here? It should be 0 1. True, it should be 0 1. What should be the earlier things? So auto increment, auto initialization disabled, auto increment mode is selected, mode of transfer will be this only. So what it is? Yes, it will be channels. For channel 1 it will be 8 5. So that is what we have done here. All of you are comfortable with this, na? That for program mode it is 8 8, and that is once you are adjusting this 8 8, of course you need to have wait, you have to 8 you have to go with 8 5. You need to go with 8 5. It is not shown here, but yes, you have to adjust it with 8 5. Okay, I think maybe some data is not taken. I need to show you another program from the textbook. Okay, so it is 8 5. You need to adjust 8 5. So that is done. Then you have to adjust your command register as well. So till time you can think of command register, I will show you the program right quickly in the book itself. So till time you just adjust your command register and give me what should be the value of your command register. Is it visible? See, so what that is what I was telling you, that you have to write 88 and then 85 to your what you can say, uh, this register. Okay, so this is how you can one by one you have to do. Once you will, if you are writing 88, that means you are programming the mode of channel 0, and then you are writing 85, that means you are programming the mode of channel 1. Okay, so that is all that are the things. I think so. This is the same one. This is the same thing, right? And here they have worked to what you can say, to make your initial bits. To they will put the data to they did it for the hard coding. Latch B is storing. Latch B is latching the uh, initial 816 to latch B. They have hardware such that A19 to A16 lines are latched using latch B. So whatever the input to latch B is, that means whatever you will provide as your A3 to A0, in latch B that will be latched in A19 to A16. That you can see with the program even. That this diagram, if you remember, see, this is latch B. This is latch B. What it is? What will be the output of latch B? In latch B, the output will be. You can see it here. It will be A16 to A19. See, and it is latch here. And what is the input to latch B? Latch B input is this. What is this? This is. Sorry, it is this one. That is last A0 to D0 to D3. That is what the input to latch B is. So how they latched it? So what they did, they took ES value. Actually, you have to store that one value, right? To A19 to A16, right? So what they did, they took ES to AX. So now what AH will have? AH will have 1 0. What was ES? ES was 1 0 0 0. So this will be your AH, right? Then that is taken in AL. So now what is AL? AL is 1 0. Now it is right shifted by 4 times. So it will be now 0 1. And now your last bits A0 or I mean D0 to D3 are now having one value that is latched here. That is how they have managed initial ones. I hope you can understand it now. Okay, so that is hardware part. In hardware, we had the latch B, that's why we can handle it in that way. Okay, so this is that part. Right? Okay, now what was your conclusion? What should be your command word? What should be the value of your command word? Okay, you don't have the ones that. Okay, can you tell me what will be the value of your command word? Tell me what will be this bit. It will be 0 or 1. Is it memory to memory transfer or it is not a memory to memory transfer? Is it memory to memory transfer? Okay, what is the source? What is the source location? Is it IO or memory? Source location is IO or memory? Source is what? Memory. And what is the destination? That is 1400 14FF. It is also memory. So memory to memory transfer, right? So it is memory to memory transfer. So what should be the value of the 0? The 0th bit? It should be 1. What should be this? Are we holding the address of channel 0? That means are we not incrementing channel 0? Is that the case? Are we, I mean, what will happen here, Dev? If we are setting the value 1 here, that means channel 0 is fixed. That address is fixed, like 100 is fixed. We are not incrementing it to 1001, 1002. We are not doing so. We are keeping that fixed. Is that the case? See, what we are doing in the source. This is also altering and same location is altering. That is, whatever is at this, it will be copied here, and whatever is here, that will be copied here. We are incrementing this as well as this. We are not holding anyone. I hope you are following the case. If you are holding, what is the meaning of this? This address is hold and this will alter. So in all this location, only data of this location will be copied. Is it making sense, Dev? Yes or no, Dev? Okay, so now let me know what will be the value of that bit. What should be the value of this bit, 1 or 0? It should be 0. Okay. Should our control be enable or disable? Enable, na? Okay. What should be, we are going for the normal timings. Why? Because it is memory to memory transfer. So we are not interested in any other things here, right? We are going with the fixed priority. Because it is very limited. We don't have multiple machines and we are not interested right now in adjusting any priority. We are just going for the normal simple operation, right? We are going for the late write selection, that is not extended one, the normal one. So again, it is 0, right? And here that is your choice, right? That is active high or active low. So let us go with the first option, that is 0 0. So what should be the value of your command register? It should be 0 1. So that you can see your command word value should be 0 1. Okay, that you can see here. The command word value is 0 1. AL is 1 and that is copied to command word register. Okay, do we want to mask any channel? We want to clear the mask. It should not have any mask, right? So our mask register, that is this one, right? This register. Okay, so we want to, I mean, that you can adjust according to your masking part, right? If you are using this register, then you can select 0, 0, and you can set 0 here, right? That means you, sorry, it is bit request, not bit request, mask register. I'm talking about this. This is 0, 0, and you will keep it 0 here. And if you are going for this, then what you will do? Okay, tell me what should be the value which you don't want to mask and which you want to mask. I mean, which you don't want to consider. So you can say that you suppose you don't you want to enable this channel whenever the data is up, you want to enable this channel, then you are going to set this 0. So again, this masking part, you can even do that, the clearing all the mask, right? So that is fine. So whatever your mask register value is, of whichever channel you want to keep enable, disable, according to that you can keep here 1. Or here what the mask disable means, it is I mean it is enabled. The channel is enabled where data transfer is possible, right? Ideally, whenever this is the case, you can keep all the values 0, right? You can keep all the values 0. That means I want to enable all the channels, and you want like from 0 only the request should be generated. You don't want request from any other channel. That is the thing that we want to handle here. So if it is the case, like if I want to keep 0 only, then I will keep this 1, 1, 1. That means I am setting the mask here. Only 0 is having, this is having, I mean enabled. This is only the enabled one. Okay. So that is what we are